Hello again. This is the third in a four-part series on how to get started on the Big Red 2 machine. And this one's going to talk about cluster compatibility mode. And this one's going to be probably a little bit shorter than the others. So I'm going to get into the right directory here. Um, I can't see my cursor. So I'm going to go into the CPU example directory. There it goes. All right. So on the Cray machine, we have our own custom interconnect, and we have our own Linux that's running on the compute nodes, and we do this for scalability. So we try to get everything out of the way, and we run compute node Linux, a very stripped down version of Linux on the compute nodes, such that when you run a job that spans tens of thousands of cores, the cores can talk to each other in a very fast and efficient way, and there's nothing getting in the way of that communication. Now, there comes a time when someone wants to run a shrink wrap code, and I like to use MATLAB as my example, right? So MATLAB is a very, very popular code with scientists, and if there's available cycles on this machine, a scientist, a researcher should be able to run MATLAB on this machine. The problem is that MATLAB is looking for a full Linux environment, and it's not going to find it on the compute nodes. So what we've done is we've invented this thing called cluster compatibility mode, which modifies the prologue of a batch job and adds additional services such that when you run MATLAB in a particular, when you run a job in a particular way, additional services will be started up before your job starts, and then something like MATLAB can run and it'll find everything it needs, and then at the end of the job it'll tear down those services and return the node into its native state. Now, I don't have MATLAB, and if I had MATLAB, I'd have to worry about having a license to it. So what I've done is I've built a script here that will build a MPI library that's not using the Cray library. And what this will do is this will build a TCP or an InfiniBand based library, MPI library package that I can then compile a code against, and I will have a code or an executable that should run on any cluster. And then I'm going to demonstrate that I can run it on this machine. So I'm going to actually skip this step here. I like to put time on this one because it takes about 10 minutes, maybe 11 minutes. So I just did this earlier today. If you issue this command, build OpenMPI, it will take the downloaded version that I got here, and it will build a TCP/IP or an InfiniBand version of OpenMPI. All right, so let's assume that I've done that, and I'm going to remove my current executable, and then I'm going to type make. And you can see that this is a very simple command. Now, this is the only time, and in fact, you shouldn't do this. If you have source, you should be using the Cray programming environment. And if you don't have source, that means you have an executable, so you don't have to do this compile command because you already have an executable. Since I don't have an executable, this is the only time that I would be running GCC directly. And I'm doing this build, and I'm saying I want to make an MPI hello world command, and then I'm adding in all of these options, telling GCC not to look in any of the Cray directories, but look in the directories that I just built. So here's my local OpenMPI includes my local OpenMPI libs and my paths and things like that. And so I've built a TCP/IP version of this code. So you want to now think of this executable here, this hello world as like MATLAB or some other shrink wrap code. Now I'm going to warn you that I am getting some errors that I have not figured out. The code still executes, but you'll see a couple of errors come by that I haven't figured out why it's happening yet. And then here's my batch script. It's quite long because not only do I run the job, but I do a couple other things to kind of prove to myself. I was using this code as kind of a test code to prove that CCM mode was operating correctly. But the important things that are different here, here's my same resource request, but this is the magic right here. So this gres is a global register, and it's like our global resource. And so this is telling the batch environment that when you start this job, start up this CCM global resource. And that'll do all the magic and build all the other stuff. And then everything else is the same. I'm going to change into my working directory, and then I'm going to do some things like check to see if I have a temp variable and some other stuff. And then if I can write who's my head node, because this will make it look just like a cluster. And you'll see it in the output when I get there. And then here's how I execute stuff. So typically you would have an MPI run command and a host file. This is all very standard on a cluster. And so you would use that same command, except you would prepend it with this CCM run, which then tells it to launch this whole thing in CCM mode. So I'm going to go ahead and launch this. I see I did it in the other order because this one could take a little while because it's doing multiple things. See, I'm going to see that I have a /temp, and I'm going to prove that it's writable. I'm going to print out my head node. I'm going to get the list of nodes that are in my set. So this would be the file that got sent to the host file name. You'll notice here I am loading CCM to give me my environment. And let's see where we're at. All right, we're running. And what's nice about this CCM mode is that these small shrink wrap codes, and they don't have to be small, I should say, that you can have MPI jobs, maybe of a CFD code like Fluent or Star CCM, and actually run on 1,000 nodes or something like that. You won't get the best performance because you are adding a layer of software overhead when you're running this mode. And so again, this is mostly just to give you the functionality of running shrink wrap codes. Okay, so we're done. And if I look at my output file, there it is. So the first thing we did was we found 64 nodes. You can see I'm spanning 2 nodes, so those are all 28s, and the rest are 29s. It's declared this first node as, or this first core on the first node as my head node. It's been able to write something to /temp, and then here are my error messages I haven't figured out yet. But if I skip past them all, you can see my hello world is executing correctly. All right, so that's it for CCM mode, and I'll be back with one more video.